Okay, this is we're going to start in another 2 minutes, but we're waiting for one more team and a few other folks. Team order, in which we're going to present. Team 2 is going to go first, give a last. Team 3 is going to go second, pollution management system. Oh, sorry, lower levels. Team 2. And then team 4, 7 spot. Then after that, team 5, handball. Team 6, color assistant. Team 16, map rover. And then finally, we are end with team 1, dementia band. Cool. Everyone okay with this order? We're going to start in 1 minute 40 seconds. Okay, let's go to team 1 to the fourth position. Team 2, then team 3, then team 4, and then team 1. Okay?
Six, eight, seven.
Okay. Thank you so much for everyone joining us. Thank you for being here. Really means a lot to us. And thank you, most importantly, to sending all these amazing makers to come down to Asylum, hosting us for the entire program, bearing with us for all the good things and bad things, and especially this entire week. Thank you very much for that. And guys, we've done the projects now. But good. I think you must be getting some updates, but honestly, they've all been working so hard for the last 1 week that I don't know how they're still standing, but they have a lot of energy and they're super excited to show you guys what they've worked on. So I'm not going to talk a lot, but I want to talk about a few things, few important things before we start. First thing, today is day 0 of the program. Anyone know why we call it day 0? Well, it's the countdown. Perfect. Thank you very much. It's the beginning. It's the beginning, hopefully, for their maker journeys, for their lives to begin as makers in this entire world of making and hacking stuff. So we think this is not the end of this program. We think that it's just a little bit of a spark that we've tried to put in. That's hopefully going to go on forever. So hopefully this is not the end. This is the journey where it starts with us. Well, that's our space where you guys are. Thank you so much for coming all the way. Let's take a look at what happened so far. So we started on day 1. I'll put off this slide on top of us. Yeah. We started by getting to know each other. This was day 1 of the program when everyone got together. Most of us did not know where a lot of you guys were from, and anyways, anyone at all. But we also got to go to the riverside with Kazan, learn about a little bit of the Goan culture. We discovered new skills. Everything that you see over here has been made by everyone right in front of you. They've worked really hard on a lot of new skills and put things together. You can ask them all about it later. But we learned about woodworking, soldering, laser cutting, 3D printing, and a lot of different skills machines. How is that, guys? How do you feel with the machines? I'm asking you guys. How do you feel with the machines now? Comfortable? How do you feel comfortable with the machines now? Big guys. Good. Okay, so it's so nice to see them use all the big tools, learn some skills, discover new tools. What do you guys think about carpentry now? Good. Not good. Good. Nice. Explore some more. We spend a lot of time exploring, trying different skills, but at the same time, experimenting with projects. Yeah, this is all of you guys doing some awesome work. Spending nights at the space, doing I don't know what. And a lot of frustrating times, a lot of confusion. Who was confused during this 1 week, or who got frustrated as well? The things not working. Okay, that's good. Well, that's a very essential part of the program. What do you guys think about board game night? Play some cool board games. Yeah, board game night as well. Got to play some interesting board games. Have a lot of pizza. Have a lot of fun stuff. And hopefully have some good mentors. How are your mentors, guys? You good? Good. Let's start off from all of them. Nice, really helpful. Yeah, nice. And who all did you guys meet? Anyone wants to yell out the names of your favorite mentors? Dakshan sir. Nice. Sahil is also there. Don't forget him. Okay, awesome. Okay, with that, I don't want to spend a lot of time. We want to start calling upon each team. Oh, these are all team photographs. Your team photographs in there. Let's see. Team Agis, Agis, Blue Labs. Are they in the order of who goes? No, right? Crunch Labs, Map Rover. Okay, let's go. So now we're going to begin. I'm going to call upon each team. Each team will have about 5 minutes to present to you guys. Some of them have some slides, some of them will show their demos. You can ask some questions, if you have some comments, please feel free. And then after that, the idea is that they'll spend the entire week making things. So some things may work, but apart from that, we really believe in what working over here. You guys want to tell them what working for is before we get started? Anything that can go wrong will go wrong. That's right. That's the only thing that we believe in at Asylum. Anything that can go wrong will go wrong. So please be prepared for everything to go wrong today. And please be prepared for none of the projects to work today. And if they work, that's a brownie point. With that, let's start with team number 2. Yeah? Okay, cool. You can just have my laptop. Here's the, yeah. Okay, you want to connect? Yeah. Let me see. Click on the slide. Good afternoon, everyone. Before we begin, I'd like everyone to do a quick little experiment. Take out your phones and just imagine trying to use it without your hands. No typing, no scrolling, no swiping, nothing. Suddenly, something you use hundreds of times a day becomes incredibly difficult. In fact, the average person touches their phone over 2,500 times a single day. Most of us never even think about it. We just interact with technology naturally. But for millions of people around the world with motor difficulties, this is not just simple imagination. According to the WHO, over 1 billion people on this earth suffer from motor disabilities.
That's roughly one in every eight people on Earth. To put that into perspective, that's more than the entire population of Europe. Yet most of the technology we use every day is designed around one assumption that everyone can use their hands in the same way. So we started asking ourselves a simple question: what if technology were adapting humans instead of humans adapting to the technology? What if your body itself became the controller? The four EMG sensors that we're using in our project pick up tiny electrical signals produced by our muscles, and they get used to control a video game in real time. No keyboard, no controller, just your muscles. And honestly, this project didn't start with some grand vision of changing the world. It started with five students, a pile of wires, several questionable engineering decisions, and a dinosaur that absolutely refused to jump. We spent hours staring at graphs that made no sense, code that worked yesterday but not today, and sensors that seem to have a personal grudge against us. But somewhere in between the debugging, testing, redesigning, and the occasional panic, we realized we might actually be building something new.
Our project uses EMG sensors which detect the tiny electrical signals your muscles generate whenever they move. Every movement in your body, even simple flexing of your wrist, creates electrical activity. Normally, you cannot notice it, but EMG sensors can. We realize this technology has applications far beyond gaming. For many people recovering from strokes, injuries, muscle disorders, rehabilitation, exercises can become repetitive, exhausting, and discouraging. And many assistive technologies are either expensive, difficult to access, or very intuitive to use. So our goal again, can we create a system where muscle movement itself becomes a natural way to interact with technology? And because we are students, the first thing we tested it on was the chromography.
But getting to the final working prototype was quite easy. Also seamless and noisy and hard to explain. And after trying to debugging, we realized the wire was being plugged in. So basically, our first few prototypes were core tests debug. I think around a six prototype worked, but then the next day just stopped. So after that, we switched up code from more reliable one, and then it started working again twice.
Our final system combines EMG sensors, the ESP32 microcontroller, a custom-built web page, and a CAD-designed enclosure. The EMG sensor is attached to the muscle, which where it detects electrical activity generated by the muscle's movement. That signal is then processed by the microcontroller and converted into real-time game controls. Okay. Now we should be some demo.
So as you can see, Ashley's flexes her muscles with dynamic jumps. So one of the sensors is configured to jump and the other one is configured to duck.
You also like to play with it.
Yeah, sure. At the end, we can let the people talk a little. At the end.
I mean, when you after presentation is over.
Yeah, so after testing this for a few hours, we realized that this might be one of the few video games that actually counts in exercise. But beyond gaming, the same technology can be applied to many other areas, such as rehabilitation systems, prosthetic control, aesthetic assistive devices, and hands-free interaction technologies. Imagine rehabilitation exercises being interactive instead of repetitive, or someone with limited mobility being able to interact more naturally with devices and games. That's where this project becomes bigger than just an arcade.
This project changed the way we think about technology. At first, it was just an idea that sounded interesting. But over time, we realized it represented something much more, which is making technology more inclusive. A lot of people with disabilities are often excluded from experiences that many of us take for granted, whether that's gaming, digital interaction, or even simple communication. And while our project is only a small prototype, it shows how small innovations can create more accessible ways for people to interact with the world around them. For rehabilitation patients, something as simple as controlling a game through muscle movement could make therapy feel more engaging and motivating. Instead of repetitive exercises feeling clinically exhausting, they could become interactive and rewarding. And for us, as a team, this project taught us something very important. Innovation rarely looks impressive in the beginning. It usually looks like failed tests, broken sensors, confusing graphs, and debugging sessions. But slowly, those small improvements turn into something beyond. Today, we're not just showing an arcade controlled by muscles, we're showing how technology can become more human, more natural, and more inclusive. This project started with one simple question: can muscle signals control a game? After weeks of debugging, experimenting, redesigning, and teamwork, the answer is yes. Thank you.
Also, great job, guys. Well done. Uh, okay, awesome. You guys can see the project, but afterwards, the video is set up so you can play with it. Any questions from anyone? Any comments or questions? And then we'll go to
this speech that there are over 1 billion people in the world suffering from motor disabilities, and they can't interact with technology as naturally as we can because most of the technology we use today depends on physical interaction, which I mean a lot of the people on the planet just don't have the ability to use such technology, which is why we were sort of inspired by them. So they were sort of idea for this project.
anyone else?
How to differentiate between different signals.
Okay. So,
Yeah, so this is a project. This is a sensor. How do you differentiate between the
So essentially, what the EMG sensor does is that when you flex your muscle, it gives us a voltage. The voltage ranges from 0 to 3.3 volts. So depending on how you flex your muscles, the voltage changes and therefore corresponding to the electricity. A microcontroller just reads that voltage and converts it to signal.
So we have signals ranging from 0 to 4095. So we can even set a range or a value if the signal at threshold. If the value goes above it, you duck, you take the signal as go. If it doesn't pass over it, it's a no.
Because we are doing this because it's extremely noisy, so we just say actually threshold. Current threshold is not possible. We are talking this machine or
So that change for different parts of the body.
Yeah, each muscle you can clear a signal from. That's why you have to pick which muscle you're tying the EMG band to. it will be gained for each person. The threshold can be reduced
So, depending on visibility, you would change the muscle. But ideally, for the best signal and the best resolution, you'd rather choose biceps and quads.
Great work, guys. Next up, we have team number 4. This is actually really cool and exciting space that's going with EMG signals, using brains to power up different games, different gadgets. It's quite cool. Today, with this sensor company. Team number 4. Yeah, I know there's a little change here for the last call, 744. Good.
Imagine a world where people don't have to risk their lives. Uh, People don't have to risk their lives to visit. Uh, Risk their lives to visit some risky and forget it. Imagine a world where people don't have to visit their lives in risky and dangerous hazardous situation. You don't know what's going on inside. There might be fire, there might be some toxic gases, there might be someone who needs help. What if there was a situation? Would you be the first person to enter that situation? If your answer is yes, you are either extremely brave or you haven't thought about the question much. That's exactly why we built this project. We are Project Ham from Asylum, India, and this is our Mayhem Map 1, which is basically a gesture controlled surveillance bot. Uh, Instead of sending a person into the danger first, we send the bot. The bot cannot only move through the hazardous areas, but it also has a camera so that we could obstruct the obstacles easily. Uh, we don't need a you know the and the coolest part is that we don't need any complicated controller. We can just use our hand gestures to control the rover. Here's the hand gesture. Here's the remote kind of thing which is controlled through our hand. The rover follows the gestures. Yeah, that's.
So what does a hero need? A hero needs information before entering danger. They need to know what's inside before risking their own safety. Because running around into a dangerous area and hoping for the best is generally not considered a good strategy. That's where our solution comes in. The operator wears a glove containing an MPU 6050 sensor that tracks the acceleration in the movement of your wrist. Hand movements are converted into commands and transmitted wirelessly using an ESP32 microcontroller communicating through ESP9, a wireless communication protocol. We chose ESP now because it provides fast, low latency communication. In simple words, move your hand, the robot moves. No buttons, no joysticks, just instinct. Which honestly made all of us feel like superheroes for a few days. Meanwhile, an ESP cam is mounted on the rover and streams live video back to the operator. The rover also carries a gas sensor that continuously monitors the environment. So unlike us during exams, it actually notices warning signals. And yes, the rover you see here wasn't brought. We designed it, assembled it, and programmed it, and tested, and improved it ourselves. From CAD models and 3D printed parts to the final working prototype.
So what changes do we make? Before, people risked their lives because of lack of information or barely any. Now, our rover goes first. The camera acts as their eyes. The sensors act as an early warning system. This allows them to make safer and faster decisions. And the best part is how natural the controls feel. It's
It's nothing but a child's play to understand. Think of it like sending a friend into a haunted house before you enter. Except this friend doesn't panic, doesn't complain, and never says you go first. And here you can see the final rover from different angles. Each part represents weeks of testing, designing, troubleshooting, and redesigning, and enough debugging to make us question our life choices.
Of course, building a project is never easy. Hundreds of brainstorming sessions and troubleshooting. And at the end, the problem turns out to be just a small group of people. We face challenges with accessibility, wireless communication, camera streaming, and power management. There were days when the camera worked but the motors didn't. Days when the motors worked but the sensors didn't. And a few memorable days when nothing worked. Those were definitely not our favorite. But that's where the learning happened. We learned electronics, programming, 3D design, CAD, rapid skill solving, prototyping, and whatnot. Looking back at our journey, the hero is the first responder. The goal is to inspect dangerous environments safely and help the hero. Then, the obstacle is limited visibility and perseverance. The tool is our gesture controlled surveillance robot, which we name Mayhem Mark 1. And the transformation is simple. The war ends first, humans stay safe. Better information leads to better decisions. Finally, all our code, designs, and documentation are available on our project website because we believe innovation grows when knowledge is shared. So, thank you everyone. We are project now. It's me, Akash. I'm going to be.
And I'm here.
And this was Mayhem Mark 1. Proof that 4 students, a lot of determination, and a surprising number of hours can build something useful. We'd be happy to answer your questions, assuming that isn't under the
Now we would like to show you our project.
Also, Murphy was kind of detailed. So good. Any questions? Any quick questions? Yeah, we can do all this later. Okay, cool. Any questions? Yes, go ahead. Go.
I was wondering how is the gesture different from the one that you did in Asylum? Because what was Asylum happened without the gesture? What's the difference in why it
So basically, one gesture control is easy and it's like a child's play. You don't need to, get instructions. You just need maybe, have a remote for a console. Basically, we have SAPSI. You need to learn through the manual that you need to use this joystick for this and this for that. And then we use gesture control because of that. And looking at the EMG sensor that is used for muscle interaction, muscle interaction can be extremely tiring and also, not very efficient. So that's why we chose to use the gesture control.
Is gesture controlled by line of sight? To which visible the rover relates to the world? Is it by vision or camera based or how exactly?
As my intention that we using is to build it down, which provides a light field of surroundings. So that's what I'm doing.
What was one of the biggest challenges that you guys faced, and what was the most aha moment for you guys?
So this challenge was actually curiosity. We were not sure what we had to do because for the first time I had met these people over here and we were not much of a team on day one. But then as soon as we progressed, we have grown up to a team and The aha moment for us was when we built this. Basically, 2 days back. We tested it, it was working perfectly fine, and we could on cloud nine. We didn't believe that was us doing this. Thank you.
Amazing. Good. Any other questions? All right. Pollution mapping system. Are you guys ready to go? Okay. One. Team three. Pollution mapping system.
Hey guys, we're team three. So I'm Arjun. This is Kahar, and one of our members who was sick, so she had to leave, but she's Nishka, so hopefully she's watching with us. So what we created was a pollution mapping system. How we show you how it works and everything. So we basically did this because first of all, my mom is really paranoid. So about all the air, if you're breathing good air, wear a mask. So that was mainly why I wanted to do this. Like tell her so she can also know within the house how it works. So let me show you where this is going. So, what was the problem that exists currently? So one of the major problems that exists currently is that most like government-based sensors and websites they don't give you accurate readings. Like they probably only give you general readings. Like for example, if you search what's the AQI in Mumbai, it only give you like the whole general AQI in Mumbai. But what this solves is that they're giving hyper local data. So this is one of the major problems that we're fixing. Also, the second problem that exists is the weather app. So when you open the weather app, it shows you like the weather, like the humidity of all of Mumbai or Goa, for example. On the other hand, what we did was it creates this of your own house. Obviously, you don't want to know what's happening like a day when you're living in Kafkare. So this exclusively gives you what's going on in your house. We know what's the AQI, what's the humidity. It makes us decided and not just the book. It's very specific and not generalized. So, how does this actually work? So, we created 4 sensor nodes. So, these are the sensor nodes. So, it consists of an ESP32 which acts as a microcontroller. We have 4 sensors, which is the DOC sensor, the visual creator, the MQ135, the DOC sensor, the UV ray sensor, which is the MN8511, and DHT22, which shows temperature, humidity, and heat index. So these four are the sensor nodes, and we also have a hub node, which is that one. So all of these sensor nodes send data to the hub node, and the hub node is basically acts as a sensor node. Yeah, so how we did this was a mechanism called the ESP now protocol. How this works basically is these 4 sensor nodes, we couldn't use Bluetooth because ESP now protocol doesn't work on Bluetooth like we do. So what we had to do is we had to connect all these 4 sensor nodes so that they could communicate with each other using IoT. And these 4 sensor nodes, the information which they and data which is given is sent to the main hub node using ESP now protocol which works on IoT. And this basically is a web page is over here. So we had to do this by forcing everything on the same Wi-Fi channel, and so we get to the same hub node. And then after 50 or 60, God knows how many tries, it finally worked yesterday at like, the last minute, which went really good. So yeah. So what are we using? So yeah, the main sensors that I said was ESP32 and MQ135, which shows carbon dioxide. The DOC sensor shows like gas extremely dangerous. Next is GST22, temperature, humidity, and heat index. Heat index is basically what it feels like. It's a product of humidity and temperature. The MN8511, which is the UV rays, which like obviously right now it doesn't show because they're inside, but when you go outside, if you go outside, the MN8511 comes to you. So we use soldering and 3D printing. So each of these sensor nodes, all the components have been soldered onto a zero PCB, and when we solder it, it becomes much more durable and also looks more organized. And helps using 3D printing, which basically sort of protects the sensors into a more weatherproof situation. So this is how we started. First, with like each individual component having no idea what each does, and then within 2 to 3 days, we made this circuit on the breadboard. Now this is really messy, so we decided to solder it. So this is a breadboard circuit which we made about day 3, which we will connect all 4 sensors together, but we couldn't make them completely with each other still. So we had to think of a solution for that. So right now, so So as you already know, we soldered and we designed a 3D casing on CAD like that. So we had to like cut out the specific holes and like make it more on CAD. And we soldered so Mishka and Arjun soldered it in the electrical room. So what are the main challenges we faced during these 7 days? The code not working. That was the first big problem and the most important problem, biggest problem that we had. Maybe after 5 prototypes, the code finally started working, so that was a big issue. The map which we created was not opening, it refused to open, but like with the help of Claude also, some credit you have to give AI, it really helped us. With the credit of Claude, we fixed this problem and finally it worked. So that was a really, that felt really good because we took that took a lot of time to work. Then the ESP and all these refused to interact with each other. We went to an extent to like the bringing two sensors close to each other and saying talk to each other. The people from different teams came and I think told the sensors to talk to each other. That didn't help. But then eventually it worked using like by realizing that it the Wi-Fi channel. Then the next problem we faced was that the UV index calibration was off. So whenever you were trying to test the UV outside, it would not like it was like stuck maximum on 50. Like even if you go inside, even if you go outside, it's always stuck on 50. It's like a really high number and like it's quite dangerous. So we fixed it in the code and then yeah, now we're getting accurate readings. And also the node 4, which is like one of these sensor nodes, it takes quite a bit of time to like send data to the map because all 4 of these are trying to communicate together and we used to try to fix this problem yesterday, but we cannot fix it. So what does this do and why is ours exclusively good? So it calculates the UV index of inside your house and outside your house. Why would you want it? If you set your kid out to clean, you want to know if you put sunscreen or not, how the UV index is penetrating your skin. So we give you that. It also tracks like air quality both like from 4 different places. Like the air quality in the kitchen is different, the air quality in the living room kitchen is different, and like carbon monoxide is something you do in the garage. We can measure that as well. So we use it in different places. And we give you real-time alerts. So like when to keep your window shut, when to use sunscreen, when to open the doors, when to make sure ventilation. Uh, so now these are the next steps. What we're going to do in the future. So we are going to right now especially yes, now these sensors can barely communicate within like maybe max maybe 5 to 10 meters. So yeah, so only maximum within your house can communicate. So we want to increase this and make it like kilometers, so you can have it like quite wide different like far apart areas. Then we also want to like right now the map is on like a specific web page that is only available on that local device. So we want to make like a publicly available web page that everybody can access, and we want to collaborate with the government and to make this help the solution better. Yeah, and impact more people. So now we can do a live demo. Yeah. So you want me to see how it works? So these are our 4 sensor nodes. Each has a power source. Over here is a laptop and 2 power banks. So these are our 4 sensors. You have to look at them. LED saying that it's on and the ESP32 because it's on. Because these 2 lights shows that it's working. Then we send this to the hub node. This is the hub node. It receives data and in our code, if you want to see it, it's a bit complicated. But it says that it's receiving nodes and the packages from each sensor node. Once this comes, we know that it's going to it's on the web page. We enter the IP address onto the web page, and here all the information in the map and also the site for better and more easy. Thank you. What are the current data here? What the information there? This is note one. This is one of the notes. Okay, fine. So, like, it's like really hot. So it's like 36 degrees right now because the relative humidity is 61.2%. Since we're inside, obviously the UV rays are will be present, so it's just 0.1. That's normal. The VOC means the like the dangerous airs are not present as you can see in this reading. The carbon dioxide is like 400 ppm, but it's excellent. There's no problem right now. And the heat index is 50.9, so that's the product of temperature and humidity. So that's the heat index currently. These are the readings we are on right now. And then this, we have a map and we have for each node. Right now it's very scroller, but like we can put it in across the house and you could see. Yeah, sure.
AQI is not displayed. AQI.
No. And like these things like a general. Yeah, these things like this like tell you like the this and this like these should be like this like calibrated. Yeah, I will show you later on. Questions? Yeah. Because it's about exact approximately like in dollars like $50 like $20 per inquest sensor. And currently one inquest sensor like if you put it there it's like $500 for one. Where you think like each is $20 only and then we keep it different cost per house. The current sensor which is like you don't want to know only the mall like you want to know the UV outside not inside. So we have four sensors for that.
You guys back to putting all the time that you're going to do it for the product.
That's the next step for you to teach them how to price it.
So, hey. Right, thank you very much. We don't like most questions, these are all prototypes. Next, what do we have? Team number, okay, we're done with position planning, we're done with surveillance spot, we're done with handball. Right, guys, let's do handball, and then color assistant. Alright, get it.
Yes, really.
I think it's pretty on the backside.
Here's what you think. Okay, so our team had control escalate. I'm Aisha. That's Pransh. That's Mayank. And that's Jay. We created a handbook. So before we get into this, I want to ask you three questions. Raise your hand. Don't have. Okay. For the kids, how many of your parents have had the ability to get up before you drive? This is not just for kids, adults. My parents are really big into the things of this. I have to tell them that like 20 right now. So adults also. You guys, your screen time limit is kind of scary to raise your hands. It's for adults. Okay. Second question. This is more like this is something to be proud of. When you're in that really hard working zone, like when you're studying, when you're working, and you really need to take a break, and you're really stressed out, and you don't know what to do. Have you ever felt like that? And the last one is super nice. My name is really bad, but I think Jaden's is a little bit bad too. So this is also for me. So the handball mat is great for having terrible. How many of your name is really bad? Okay, not so good. I can just do. Okay. So the way it works is we got into that okay, themes was. So this game can be It's really put up anywhere in your house. Yeah, it's really big, but you can put it anywhere in your house. So this is a working prototype right now. It's not done yet, I know, but you can keep it on your wall. You can keep it on your desk. Right now, we just brought it over here. So this is basically a platform series and it connects in a way that's really fun and productive and also gets you up your match. So basically, this is what we built. So this is
This is RC indicators. This is the car that they did. This is how distribution works. So when in the ball on this, it actually has a more aspect. It is not too much time. So it's currently higher and higher. There is another wallet. You can see that score and yeah.
So I'll tell you how it works. So this is the ball that you are going to aim at this. So this is our velocity pressure band. And when the ball comes over here, first the target will be displayed when the buttons are clicked. And you have to try and aim. You have to try and aim to hit more precise. The more precise you are clear, you are to the target to get more points and vice versa. So this is an OLED which will display all the points of the person 1 and person 2. This can be multiplayer. It can be played by two people also. And so there will be player 1, player 2. They can also make teams of 2 to play this game. Yeah, so
Okay, I just talk about what are materials we use, right? Because this is quite an extensive system. First, obviously, we have thermostat mat, which is really cheap. I mean, it's surprisingly cheap for such an important purpose that it serves. Essentially, it changes its resistance when the pressure is applied to it. Then, obviously, then we have this stuff, which you can't really see. It's like copper tape. So, one of the things that we actually had to do was use multiple lines of copper tape because we actually have a very low width. So, we had to use it and to stick it like this, and it looks very ugly. But in the end, I think it doesn't look too bad overall. Then obviously we have this 16 by 16 RGB grid, which is quite big. So our initial idea was to cover up one of the lines and make it 15 by 15. So that we have three trees to represent each target area. So when you chuck a ball, the sensor will detect which row and which column it is in, and it will give you points according to that. And the wallet, I mean, I understand it's very small, but when someone comes to click the points, you will be able to see it. So that is the entire idea. So anyone who will play the game will just click the buttons and see the points. And lastly, this is the stuff in the back. I think take a look at this. What a load of wires. We have probably like 80 wires, quite a few wires are there. So everything is put into this one 3D box, which is supposed to have a lid, but we also didn't have time for that because the ridiculous number of wires to be so long to solder and put together. And all. So overall, this was the entire brain of our project. This small box has every single bit of logic that helps our entire game work. Okay. Now let's talk about the most important thing, about the issues, the problems. I cannot explain to you how many issues we faced overall. I'll talk you through some of the main issues that we faced. So on day one, we were actually quite successful. And our velocity pressure mat, the prototype, which was a small one, worked beautifully. It had beautiful threshold value and it had a great range. And it was working perfectly. And then the next day, we spent around 4 to 5 hours because it stopped working. We had to get it back to the same point to keep going. So that was one of the biggest setbacks that we had. But apart from that, we also had other setbacks. Like the copper tape that I mentioned. The copper tape that we use, we worked under the assumption that the adhesive, which is actually under this adhesive which you can stick. We assumed that it's connected, but it was not. So we spent quite a lot of time sticking the tape and hoping that it would work. Which it did.
And apart from that, we also had a lot of issues in like soldering and laser cutting. And essentially, there was a lot of problems that we faced. And essentially, the program stopped working whenever it wanted to. There was no reason, nothing changed for the program to stop working.
So, so we had 6 days full pack of making this, and each day we move step by step forward. So on day 5 and 6, as you can see, so today it didn't show up as expected, but please again try to make it good. Yeah, we were working till now. Whenever when these people were explaining their projects, we were still working there, trying to make it work. So, but it did.
Let me just cover the numbers. Yeah. So let's conclude quickly what we learned through this. Alright. One of the things that we had that was really nice was each and every single one of these components work wonderfully on their own. I mean, you could tell like, each of these maps, when you connect them all together to our board, they work amazingly. The OLED showed everything with crystal clear clarity. The RGB was absolutely amazing. The board was written with data, really good. And the button, but when you put them all together, the code just had a hard time working. It was just something that we failed to prepare for. And sometimes it just happens. We fail to account for what happens when you put multiple things together. Because the amount of things that we need to check exponentially increases. Now we have so many more wires to check every time. Just in case something not working. Another thing that I think we all learned, and it's something that's applicable everywhere in life, is patience and persistence. The number of times our college failed, but we kept coming back to it, we kept working, and we kept giving it our all. Till now, till 10 minutes ago, it still didn't work, but I think we learned a very important lesson. And one more thing that we really learned was the importance of taking breaks. So we worked in a somewhat format where you work for about 90 minutes and took a 10-minute break. Just so that this helped a brain refresh and not get tired. Because I think anyone in this room, everyone in this room can use. And then anytime you work non-stop, you will feel exhausted and your brain will be fried. Like today, again, so I keep coming back to this example, but we've been working for so long that by the end of it, we were confused as to which components did what thing. Because we were just working so much. Like we even had a delayed lunch break, we were working so long. So I think overall, this project taught us that things don't always work out, but it's important to keep going, to keep learning, and keep trying again. Thank you.
Great job, guys.
Everybody who catches
Nice. Well, next, who's up? Next team. Yeah. We have color assistant, team number 6. Well, let's go. Please continue. Let's go. Go. Go.
Hello everyone, we are Team 6. I'm Krishan, he's Arjun, he's Chris, he's Rahul. This week we've been working on our project, a colorblind assistance glove. What is colorblindness? Basically, in simple words, colorblindness is when a person is not able to differentiate between colors, mostly red and green. colors do not be understood. We have many problems to solve every single impact.
So, like, before I talk about why we built this color system now, I would like to talk about how we reached here. So, in the beginning, we first thought of a device that checks the brightness of fruits, or like a pH level of milk. However, those like projects were very complex and not feasible. So then we were brainstorming, and then Aroma, he thought of a good idea, which was actually very interesting story. So Aroma's brother grew right? Yeah, he's colorblind. So we actually made a colorblind map for him. So he can like tackle all the challenges he faces and it helps him in daily life. So like what we need from this is to detect colors, is make it variable like you can detect it wherever you are. You don't need a phone or anything with it. And lastly, it's keep it affordable, which I'll talk about later. And to show the result almost instantly. So like how it works. So so like first we have a color sensor which has a built-in LED which you can point at any object. For example, we have like a token over which will be color. So the built-in laser points at it and gives information to the ESP32 which is the brain of this device. It receives all the information and like it interprets the information and sends it to the OLED display to give the color and then explain in our GPU. That's how it works. So over here it's you point it at the object and the color sensor senses the object and like identify the color. And then sends it to the ESP32 microcontroller. The ESP32 then gather that information and then it's displayed on the whole display screen. So this is a very important slide actually. Because what's inside the color. So first we have a ESP32 day module and the price is around 250. Then we have a color sensor, the price is 250. The whole display screen, the price is 150. The battery which is in his pocket, that's 250. We have clock and that's about 130. So why the price is important? So when you start this project, many people ask us why color and clock. There's already like a glass there when you see it tells you which color. But the problem is that costs about 30,000 and the other solution costs 80,000. Like a common man won't be able to afford that. So this product only costs 1,120 rupees. That actually helps a lot of our society. So use a color sensor, which is a TCS 3475 sensor, to find the color. To find the color raw color value, and send it to the ESP32 that it's a microsensor. And it is a microsensor. Then it compares the color code. Of course, processor very outside right on the evidence. Then the compare against a data mix of colors, mostly common colors. And when it goes it match with the business formula, and then it's show the details on a display. Over and over. So we are not always going to go to the it's kind of hard to do some powder class. Solution is on open source. Yeah. And Corona classes were not actually part of open classes because they only work for like one kind of program. And another the problem was like the color. So, like a color is specific RGB value. For example, black has 000, like any color will take the code. So, like the problem was sometimes it gives like a like 1 to 2 degree less because the light over here, and the sensor does not be able to sense that. So, that's the problem with the code. For example, earlier thing with the Azure base, is like the current key were most of all. It was almost saying brown was clean, almost really clean. And most red changes not which were there, it was not so good. So when the report was smaller than the base, I was steering them more than the others. So I had home open we got data right now. We use the answer ID to write a code. And this very common language to write code. It is to have the answer. And this is how the code over.
So what it can do? It's very easy to wear. It's a very easy to wear product. As it's mounted on a glove. This is strap of velcro that is stuck on the sleeve and box via double-sided tape and more double-sided tape here to stick this product. It is supposed to make it easier for people with different wrist sizes to wear. So that's why we put that extra lens here. Then we have it's not like if I scan you and wait for 2 minutes for the color. The minute I scan this, it will show me what color is box. I don't have to wait. Then we have a database of 10 colors that we expanded. A few of them are red, green, blue, basics. We go over to RGB, first asserting the dominance, which color dominates more, and then there's additional others. After which it is standard. You don't have to get a phone out, app, or connect it to some super device. You will see your color right on the hand. It's very accessible. The output is very relatively large, so it's difficult to be used. It's not like it's very small or that it's not that difficult. And it's low power. The power is at 5 volt battery and 5 volt battery lets it last for quick day. So where it actually helps. As we mentioned earlier, school and study, where it can help design and help in part of the community. Then depending on one part, whether it was from, let's say you want to get something over maybe colorful with your friends. It helps in that. When colorful what you're doing, you can become more active with your friends. So let's say you want to try this color because you are often seeing people, you are often with people. So you say that I want to take this color, but you don't know what it is. So here you can scan it and see which color is the better one for you. What is this is very important because the men fire the colorful to what is where what goes. In this scenario, the workplace, this will allow people to realize what bias can be made, what bias can't, what is safe, what is not safe, what is safe after. Health and safety, medicine, you mentioned this earlier. Medicine can be very easily mixed up due to color. You know, understanding the color code. And in everyday life, like traffic light, art project, many color light people actually suffer from deadly, which actually makes it harder at traffic light if you don't know that already. Uh, obviously, in action, the roller is there after connecting. We have when we used to see like the battery at the end, post the battery, you will see the
We had our limitations in our project, so the sensors were small games. So it's not like pointing out I expected to work. I don't know about this systems. Then there are sometimes I know outside, those were this after a weekend and they will lot harder. Then also the giving thing is sometimes too. But we have other labs like this is AI and then this is applied, this is arrange, this is access.
This is the most important reason of our project, not the accessibility and affordability. So, like I said before, the reason we made it was to make it affordable and accessible. So, as you can see, there are different types of colorblind solutions right now in the market. One is like how we are making currently. There's one of the end glasses, which top on setbacks and the app. So the price of the app is about 500, but the setbacks are you need a phone. Right? You can't see without your phone, and it's not very accessible. Sometimes you don't have your phone in school, you don't have your phone, but you still access objects. Then the L classes, it's very expensive. That's the biggest down the reason of it. And secondly, it's not very accurate. And so sometimes many of the time we misread, see the colors, and the accuracy is a really big problem for the price. So our glove, it has everything. It has the factor, the ribbon, and screen, names, colors, and affordability, which none of the other projects right now in the market have. So that's a big differentiator, the accessibility and affordability, and that's the main reason we do this project.
Any questions? Any thoughts? Yep, go ahead.
Why the glove? Why not just a strap?
The strap would be a bit uncomfortable because of the Velcro.
Also, we tie the strap just before it's very loose, it's not stable. So we wanted something stable, something that someone can wear in school. Like from now on, we can wear it in school and it really help it because it's stable.
So we have blue, which I believe is in my video. So this is how it goes with blue. Yeah,
Team number one. What do you guys-
then we have green, and lastly we have red. All of them are suitable on the roller.
Amazing. Thank you guys. Right, the last two teams of the day. Dementia band, team number one. Go for it. Go for it.
Yes, there is. That's right. He's my father. I was planning to book a follow-up appointment with Dr. Jenkins. Obviously, yeah. Yeah, that's fine. Okay, thank you. Bye.
Are you alright? How far along are you? Well, I was just wondering how long.
It was 1 week. On Tuesday. I mean, 21 weeks on Tuesday.
How long to go?
It's easy for you to say.
It's time to get tough. You must be excited.
I'm scared.
Of what? I'm sure you'll be fine.
People say that, but I'm not.
Sure you'll have to. You'll manage. Everybody does.
Do they?
What about your family?
It's complicated.
Don't get on.
It's just me and my dad. And he's sick. So,
You should be okay.
Jesus.
So I hope you all saw the video. So before we start, I'd first like to introduce me and my team. I'm Aryan.
I'm Tanya. And I'm Megashri. Um, I hope all of you all understood the video. As an exercise, I would like everybody here to close their eyes for a minute and just imagine receiving a phone call from a person, from a loved one, and just imagine receiving a phone call informing you that a loved one has gone missing. Imagine them perhaps stepping out of the house and forgetting the way back or forgetting where they were. Scary, right? For 60 million families around the world, this is not a hypothetical situation. It's a heartbreaking reality. One of those 60 million families was mine. During the last 10 years of his life, my grandfather suffered from dementia, a disorder that causes complete memory loss. There have been countless such incidents when we step out of the house confused and lost, leaving my entire family that lives in a different state from him, worried, anxious, and unable to help. The emotional toll on our family was immense. Every minute he remained missing increased the risk to his safety. Studies suggest that approximately 60% of people with dementia will wander at least once during the course of their illness. In many cases, patients leave safe environments, believing they are going to work, visiting family, or returning to homes they lived in decades ago. A few minutes of confusion can place a vulnerable individual in a dangerous situation that can result in serious injuries. This project was inspired by the need to provide both protection for patients and peace of mind for caregivers. By leveraging wearable technology, wireless communication, and SMS systems, our solution places virtual safety boundary around dementia patients. When a patient moves beyond this designated space, caregivers are immediately notified via SMS, enabling a rapid response to a minor incident with one's instructions.
So I'm going to explain a bit of the technical aspect of this project. So we use the ESP now protocol due to which two or more ESPs can communicate together. So we use two ESPs. One is in the badge and one is in this receiver. So they both communicate together, and depending upon their signal strength, a message, an SMS might be sent. So now how will an SMS be actually sent? This is where a GSM module comes in. So GSM technology requires a SIM card in it, and due to this SIM card, an SMS can be sent to a phone number. So the way in which our project works is that if the signal strength between them is beyond a certain threshold, the GSM module is alerted and an SMS is sent to the caretaker's phone number. So, on paper, this project might sound very simple, but while making it, we found lots of difficulties. So, first of all, I'd say our biggest mistake was trying to do everything at once. This certainly did not at all work out as planned. Then we divided it into subtasks. We used the format of divide and conquer, and at the start, this actually worked. On our first day itself, we managed to establish a successful ESP now protocol and could even measure the current RSSI strength. But then, as a Murphy kicked we so these two started working on a web page which might show the RSSI value and whether the SMS will be sent or not. And I started working on the GSM module. And believe it or not, trying to make this successful took me more than 2 days. Perhaps the biggest problem in the GSM was it was not detecting the SIM card. The code was correct, the wiring was correct, and I don't know why. It was just not detecting it. And as unsurprisingly as it was not detecting it, suddenly it just detected it and we could now send an SMS. But even then, there were problems. Not all the time the SMS would reach the phone, and, and we had to constantly make changes to our code. In the process, we learned many unique things. Tanya is now going to explain the software part.
Okay, so like Aryan said, we try to create a web page, website, everything else in between. We tried so many things. I created 3 web pages, I created an app through Firebase, I created a website, we tried using Telegram, we tried using Link. None of them worked. It was such a sad thing because on the second day when we were working on it, nothing worked. We kept trying and trying and trying new codes, asking ChatGPT finally what ChatGPT thought of it didn't work. Finally, Aryan was so persistent on the JSF module that it actually worked and it sent an SMS like this. So that is on my phone. It sends an SMS saying that patient may have left the safe zone or signal runs. So when an SMS comes that patient has left the safe zone, it means that the patient is 30 meters away. Signal loss approximately 50. So first this is like the end of our presentation. This is exactly how it works. When the signal is detected and not in the same range, send the So it's a very simple technology that we use. Basically, the send an ESP to send signals to the receiver, and once the receiver detected that the signals were reducing in strength beyond a certain threshold, it would automatically send an SMS to the caregiver's phone so that the caregiver would be alerted that the patient has left the safe boundary and to take action quickly. This badge is also extremely customizable based on the patient. We connected to pins on the back of it, but you could also connect velcros and make it like a band. You could work to compact the size a little bit more and customize it. So it can be pinned on a person's belt or inside a person's pocket or as a pen clip, something like that. So it's extremely customizable and efficient. Last but not the least, we would like to conclude the presentation and 7 days of experiencing this residency by saying a big thank you to the entire Asylum team. During this week, we have learned lessons from everybody here, and we are extremely grateful for all your support and guidance. None of us here knew how to do this and how to overcome the challenges that we face. But over these 7 days, you all have empowered us so much that we could actually make something like this on our own. So thank you so much.
Any quick questions before we go to the last team?
Anything? Any question?
Where everybody see just pass it on.
Yeah. Any quick questions? Okay, we have one question. Go ahead.
Yes, so like I said, patient name and let's say it's a other message. That is about 30 minutes. And it's you can increase the threshold.
But because of the ESP of like it won't go more than 25
meters. Reach the signal loss after 40 meters.
No, so it's like, for example, keep it in the center of the house. It's like a circumference of a circle.
Awesome. Great work, guys. Very beautiful presentation. project. I have in 16 Apple.
347 in the morning. A building has just collapsed downtown. 47 people are trapped inside. The rescue teams are waiting outside, geared up, trained, and ready to go. But they have absolutely no idea what's inside. Good afternoon, everyone. I'm Shreyas, and that is Ram.
Good afternoon, and I am. These are disaster response teams. People run towards the disaster while others run away. But standing at the edge of the river, they face up to no training templates. They go in line.
Their need is actually very simple. They just need a map to see what's inside. Where are the malls? Where are the open paths? Where are places where they can walk without worrying about the wall breaking? You can find the nearest coffee shop in just a few seconds. But when traversing inside a disaster zone, it's a complete blank.
You the fix is simple. Send in the camera. It's clean, it's simple, and it's the obvious solution. If you look at this, it's completely black. There's no light. Since cameras need light. Since cameras need light. For our building, no power and there's dust everywhere. And before anyone suggests a flashlight, yes, on the remote control dark, pointed in one direction, and then a multi-room collapse.
Over 60,000 people die in structural collapses globally every single year. Many in the first few hours, not because the rescue teams aren't capable enough, but because they lack information. This is not a training problem, it's an information problem.
So, unlike the camera, the LiDAR doesn't require light. It doesn't care about it. It fires thousands of laser pulses in every direction and creates a 2D map of everything around it. Walls, obstacles, open path, in complete darkness. Same family of technology is used in self-driving cars. We just pointed in somewhere to produce full.
So this is what we, so this is not we did. It's a six-speed mover which has a rocker moving system which is similar to the one you might have seen on the NASA rover. So basically, it has a Raspberry Pi and a LiDAR which senses the area and makes a map of it. And according to that, you can see the map in present.
Here's how it works. The operator drives the rope remotely from outside of the individual. As it moves through the space, the widely LiDAR X2 is firing thousands of pulses in every direction. The Raspberry Pi reads the distance data from every angle and renders it to the map. It's on a screen outside of the danger zone. Walls appear, obstacles appear, open paths in real time. without a single person stepping in risking their life.
So, what are the changes which this makes? Before, the people had to enter with zero layout information. Now that they have a 2D map, they can actually visualize where they want to go and it makes the process a lot faster. Then, the cameras feel completely because of the darkness. But LiDAR can see in darkness. So, it allows the map to be created without any difficulty. Then another thing is that there are risk of casualties for the rescue team themselves because they have no idea. Let's say they are walking and suddenly something, let's say the floor breaks. What do they do now? But when the rover goes in, it has already gone through that path, so they know that it is safe to go through.
47 people collapsed building 3:47 in the morning. Stop going in line. Let us show you.
As you can see, we can control the rover through a web and when we click forward, as you expect, it should go forward. And there in the middle, there is an axis which tracks the position of the rover. And these red points which you see are the live data points. Now, because the laptop is a little like cooked because it is processing too much data, so there is a lot of lag as you can see. But apart from that, these purple outlines are the actual map it is making. So as you can see, there is a sharp clear line in this direction because there is no obstruction. But here, since everyone is sitting, so there is no clear wall, but a few points. So, like we can control various things such as the speed and we can move it as usual. And another thing you might have noticed is the middle wheels aren't working. So there is a story behind it. When we started out, we thought of using two motor drivers. As you can see inside, this red thing is the motor driver which actually controls the motors. So to power all the six motors, we would require two of these. And having two of these here with all the wires would make it a lot messy. So we decided to use one and compromise the middle wheels. Because anyways, the slower this moves, the better the map it is making. So that is the compromise which we have. Thank you.
Wow, thank you guys, that was awesome. You guys should come and see the project and all the way that project we put together. So, well done, guys. Any other questions before we close the open house and then we put it in an exhibition format so you guys can go and talk to all the students, check out their projects, we all get together, there's some snacks and food for everyone to eat. So we do that. But before that, any quick questions? Okay. Come, Richard, let's go play. All right. Amazing. Thank you so much once again for being part of this program and spending the time. And I hope all of you had a good time. How was your week? Yeah? Okay, thank you. Really enjoyed working with each and every one of you. I think all of you were super amazing. You guys saw the amount of work that all of them put into it. Everything that you saw here is all done by them. We were just there to support them whenever they needed us. You saw that all members, everyone was just there behind them. If But with that, I'm going to pass it on to Richard to talk a little more about the journey ahead, one of the things that you guys can get involved with, and at the same time, the most important thing, this space is now home for you guys. So whenever you come back to Goa, this is home ground. This is home. This space is always going to be open. Please just walk in. This is your home now. So come be with us as much as you like. Thank you once again for being here and spending all the time with us.
Awesome. Thanks, guys. Super job, everyone. I mean, I took all their interviews inside as well, so I know what they were planning and making. But just to see, like, the final, we've been it's not like only this week, but they've been in touch with us for almost 6 months, a little bit more. So it's really lovely to see you guys and really, become confident makers. I think at the end of this, in the least. So, and then we obviously have a lot of questions about how you can go from here, what do you do next. So we thought we'd just put together a little bit of a presentation for all of you to see what all can you do.
How do you want to come back again?
Yeah, what?
Okay, good.
Okay. Awesome. Everyone wants to come back. Most of you want to come back, so that's great. So like I said, you guys have access to the space. This is home base. DevOps said, whenever you feel like coming, please stop by because now you know how to use this space. So we know that you would, use all the tools and all of those things are also great. You can be part of more programs. So the next up we have Innovation School Level 2. This is sort of an advanced making program where now you've kind of built something for yourself, maybe in a way, like you started with something like a problem statement, which was your own, build something that mattered to you. But now I think the next version of this program will level up is more around building things that matter to other people or generally the planet, the people around you, the communities around you. So this program is going to be a cohort-based kind of a program where you can come in, the alumni can come in and work with us in the similar format. There's an online and an offline piece where you first kind of work on more advanced project and then come to more advanced making later in the year. So if someone's keen on the level 2, you can reach out to us. I'll anyway share all this over email as well. The fun thing is that next summer, we also have partnered with Cornell Tech in New York and EAC in Barcelona, 2 amazing universities. And you can actually go to their makerspaces and build projects next year. So if you want international exposure to more maker communities, you can come back and work with us to come to New York or Barcelona next summer.
I'd just like to add, like, some of these spaces are pretty special, especially EAC and Barcelona. All maker spaces are very different and special in their own ways, like the one that's pretty good. There are thousands of maker spaces now across the world. And I think it's the beginning of the journey to go and spend time in more and more places. You'll find similar communities, but every community is a little different. This one is more of a design and materials community. So what they focus more on is just kind of materials, architecture, and design. So hence we really love working with them because they give us a very different perspective of how to think about materials and how to think about projects. These guys over here in Cornell, they're very different because they're focused more on robotics, soft robotics, and different things around the spaces of automated devices. So I think that's the one to go to if you're into that kind of space. So the way that we're designing each program and all the spaces that we're trying to create is actually partnerships with folks that we also aspire to be at and enjoy working with, and the folks that we've learned a lot from. Because the idea is not just go to places for the heck of it, but actually go to the community and gain different perspective. So each space that you're going to, you're actually building on top of what you've learned, you're building different perspectives, different thoughts, because I think that's really what's important at this age, and otherwise as well. To meet different communities, get different perspectives, that's what really will help shape out what you want to do.
Yeah, so that's going to be next summer. So if you guys are keen, you can let us know.
With Barcelona, we'll also be going to Paris because we've done a lot of work in Paris.
Yeah, we were. Actually, just a history of Makers Asylum. It was never a space for young, like people less than 18 years. We actually started as an advanced community space. So Innovation School is a recent addition to make it a little bit more accessible. In the pandemic, when we moved to Goa, it's when we really thought about the impact that some of these, learnings that we've had in the last, we started in 2013, so many years now, that we can pass on to the next generation. So that's how it kind of started. And Innovation School, I think our initial work was a lot around student exchanges, bilateral exchanges. France has been a big part of that journey. The French embassy has been our partner for many years. We've so it really enabled French exchange for university students largely, and these are credit-based courses for universities, give as well. Currently, we work also with Australia, with Monash and 6 of their partners. So there's a whole different piece to what we do. But Innovation School is, of course, something that we wanted to bring all of these partnerships to as well. So the Cornell and EAP partnership is sort of an extension of that whole stuff coming to the new program as well. So, and then the third thing, we've seen a lot of folks really requesting us that they want to kind of individually go deeper into some of these projects by yourself. You want to build something even more advanced. Sometimes team projects are not something that they're looking for, so we thought it'd be really nice to have something where they could work with Anul and Debha as well as a one-to-one kind of a capstone project or whatever. This is the working name of this program, but like sort of a one-to-one intervention where you can go deeper into building your own ideas as well. So it'll work in similar, most of our programs are hybrid, so things will happen online and then we'll have a physical intervention. And that's how we have, so that's another way of doing stuff with us now. You can also, of course, become alumni mentors and come back to the program. So if you want to share your skills with someone else, feel free to come in for the next residencies in winter and the summer and just hang around and use your skills to help somebody else's project as well, which is sort of paying it forward with what you've learned. So that could be another way to kind of be here.
Yeah, I think one of the best ways to be able to learn something is by sharing it or teaching it with other folks. I think that's been very key and integral to this community. Last year as well, out of the 130 students that came to make Asylum, 80 of them came back, which is beautiful as mentors. So we're very happy that the number is increasing. More and more folks are coming back as mentors, and we want to encourage that because that's how you get able to actually build their own skills while sharing it with other folks. So we'd love for them to come back.
Yeah, we'd love to have all you come back, so let us know. You can, of course, volunteer and intern with us as well as part of some of our open research projects as well that we have. Some of the projects that we do are also for community-based projects that we're working on, which is open research, open source generally. We spoke about the F19 initiative to all of them, which is something that we were doing in COVID, which is a research project. Also, a lot of stuff that we did around building open source healthcare products, for example. There's a research project that we're doing around mapping the rivers and the safety measurements for the river quality levels, right, in Goa. It's called the river pollution levels. It's called River Watch, for example. So we're working on that mapping. So you can do certain things with us, which is more beyond just be helpful in some projects that we're already doing as a space. And what can parents do? Parents can also learn some major skills. Our woodworking workshop is really popular. People come from all across the world to kind of learn about furniture design and building stuff. You can learn about metal. If you have a maker instinct, like I said, we've always been an adult space as well first. So we've enabled a lot of adults into switching gears from being at corporates to becoming, carpenters actually. So there are a lot of those stories as well where people have really switched because they were just kind of doing stuff. So from a hobby to a profession and just a way of living, I guess now. So you can also do that with us. You can be a parent ambassador if you feel like this is the culture that you really see is something that needs to exist in other spaces. Please talk about the program to more people about the space. It's always been word of mouth for us last 13, 12 years. So we love you to
mean a lot to us to send more folks. Thank you.
Yeah, that would be it. And then we also have exciting updates. We're expanding our campus in the next, hopefully, 2 to 3 years. This project is coming along, but this is something which is been really amazing because we've got the little bit of support from the local government here because they think that something like this needs to exist. So we're expanding into a much larger space now, and this is via our non-profit, which is going to be so this is going to be a much larger campus. We're starting with 35,000 square foot expansion, hopefully to 100,000 in the next couple of years. But this is by a non-profit Section 8 company, which means that a lot of philanthropic support, CSRs, and we run the same programs via CSR partnerships as well. So if you guys, run your companies, folks that would be keen to, be part of this and support us. It's going to be a creative ecosystem, one of its kind, hopefully in the country and in the world, that will really support people into achieving their maker journeys as well. So it's going to be a little bit more like this, but much crazier, I guess. So that's where we're at. So we are currently doing a bunch of work around that parallelly, and hopefully we get to see you guys come into new space soon. And yeah, we'd love to have you talk about it. If you feel like there's any kind of support that you can offer, please let us know. And yeah, now the program is really growing, so it's been over 400 plus talents from 50 plus cities. It's not just certain cities that all these young people are coming from. It's now also about 15 countries. So yeah, I guess it's kind of like a really exciting growth journey as well. The program, and yeah, we're hoping that as you guys are building, there will be 5 more cohorts coming this summer, and so we have almost really some really amazing projects coming out. Like I said, social impact and inclusion is also a very big part of what we do. So the same program is also offered as a full-time scholarship to a lot of underserved teenagers as well. So that's where a lot of the CSR work and stuff happens.
30 seconds about scholarship. So there is a 100% scholarship to the same program that you guys follow. And it's open for second generation of carpenters, welders, electricians, plumbers, mechanics. So we're actually working with a lot of NGOs across the country right now, like Teach for India and others, that are helping us identify folks that have it in their blood to make, however it is that make it, but don't have the access. Thank you. This residency, we didn't have anyone for this, but next residency offers will start coming, and they're always just mixing in. It's part of the entire program. Everyone's the same at the same level, so that's the good part. And this year we did how many students? 36 students. And this year we're planning to do over 100 students in the foundation to bring more inclusion into the program, provide 100% scholarship to the program, create folks from different communities to access the same program, the same exact thing that you guys were part of.
Amazing. So, I mean, of course, a lot of the students have got some amazing schools. It's become a really interesting portfolio piece. I don't know, somehow we did not think about it, but it's become like that because a lot of schools like MIT and others also care for maker portfolios across the world. So it really adds value when you have a genuine story, I think, which I spoke about in the my session as well. And of course, a lot of exposure opportunities. We've had over 30 plus startups come out and make a design in the last 12 years. We're starting a formal incubator as well soon. And we try to bring you guys in when you're ready for those things as well. And the program is not just for high schoolers, the space is not just for you guys, it's for all people who are interested in building and making. These guys are a great example of 2 really interesting people that came to the program. Naman, he's one of these Ivy schools, really amazing student, came from Bombay, really intelligent, and Ganesh came through our social background through Teach for India, and we, sort of paired them up. And eventually they went on to start this growth startup called Eva. This is an old article, but now they raised about $20 million. And doing some incredible stuff like really hardcore hardware work. And a lot of that base is hopefully from what they've learned from here as well. But the fact that Ganesh comes from a carpentry background, his dad is a carpenter, was really abysmal at school, but really great at hands. So it was told, the TFI told us that, why don't you take him in? And now it comes from all access, but the fact that they kind of got together and they're doing something incredible in the hardware space. I think this is the kind of stuff that can come out through really, impactful organic journeys. This is not something that we've kind of structured in the program, but they've kind of learned a lot of this stuff through the same stuff that we do over here. So yeah, so I think I'll stop with that. We have our applications open for the winters. If you guys feel like your friends would like to be here, please let them know. And yeah, that's with that. I will call for the certificates actually now because.
Let's just take a group photo.
Yeah, I think that's great. Let's do it. Let's go. Come this side, everyone. We'll pass on the certificates to all of you.
Everyone, point here and look there. So the camera is going to be somewhere on that side. Yeah. Just look here, come over here. All the parents as well. So ready to make the program. Just look here. You can use the bench or chairs to climb on top. That's okay.
Please come on this side. Guys, stay up. Come, everybody. It's fine, just let them on the. Let's just quickly do it. You guys can stand up. Who's taking the photo? No. Okay. And, so some of you sit, some of you stand.